about what heat was in our last presentation. Today we're going to talk about what heat transfer even means. Okay? All right. You may not realize it, but you do think about heat transfer several times a day. If your soup is too hot, then you let it cool down before you take a sip. If you take a bath or a shower and it's too cold, then you add some hot water. If you are too hot in the sun, then you move to the shade. Now, you do these things naturally. You don't even think about how they work or why they work. So why does it work? Why does it work to cool things down or heat things up? For example, how can a spoon in boiling water burn your hand? Or how does the heat from the sun move millions of kilometers through space to warm the earth? Why does this even work? Well, we talked about it a little bit last time, and it has to do with the transfer of heat. Heat always moves from a warmer object to a cooler object. Okay? So the temperature goes from warm to cool. So that's why it works. That's why it works. Now, let's talk a little bit more about specifically what the avenues that it takes to transfer the heat. Okay? And now you guys probably watched this in the video on Monday, but there are three different ways that heat transfer goes. First is conduction, okay? And here's my little conduction picture. Okay, conduction is the transfer of thermal energy, also known as heat energy, from one material to another by direct contact. Okay, the key word, the key phrase here is direct contact. Okay? If you were to use a metal stick for your fire, your hand will get too hot because of the heat. It transfers through the metal to your hand. Okay, that's why usually people poke the fire with wood. It doesn't travel as well on wood. Okay, but there is a direct contact from the heat to the metal to your hand. That's conduction. Then we have convection. And convection is the transfer of thermal energy, also known as heat energy, by the circulation or movement of liquid or gas. So it's a movement. There's a movement of liquid or gas, and that movement is causing the heat to transfer. So the example would be a hot air balloon. Okay, the hot air balloon rises from the fire. The heat from the fire rises in the balloon, and it is able to lift off the ground. All right, and then finally we have radiation. Radiation is when the energy is absorbed by the surface, it heats the surface, okay? So, for example, on the microwave, it uses radiation to cook the food. There's no direct contact, and there's no circulation of air, okay? Radiation is actually just the waves that are coming and hitting the object, okay? Just like the sun, there's radiation from the sun, UV rays, ultraviolet rays, okay? That comes from the sun. That is radiation, okay? There's lots of different types of radiation anytime it has to do with waves. Again, there's no direct contact and there's no circulation. All right, let's talk a little bit more about these in detail. Conduction, okay? When you warm your hands, like let's say your hands are cold and you put them on a mug of hot chocolate, or let's say you have a really hot face or hot neck and you put an ice pack on it, right? We're probably more used to that because it's so hot in Arizona. This is what you're benefiting from, conduction. Okay, conduction, remember, the science behind conduction is there is a direct contact, okay? So this is what happens. So you need to know, already, we learned in chemistry, all molecules move. Remember, they move in solids, liquids, and gases, just faster in gases, slower in liquids, and slowest in solids. All right, but when warmer molecules come in contact with cooler molecules, some of the kinetic energy of the warmer molecules transfers to the cooler molecules. Okay? This is why two substances of different temperatures that stay in contact with each other will eventually reach the same temperature. So, for example, like a book in a library, there's no heat transfer, if you remember that from the last PowerPoint, because the direct contact of the air and the book or the table, all three of them, they've been in direct contact with each other for long enough, so they all came to be the same temperature, so there's no heat transfer currently. Just like if you're defrosting meat, a lot of people will defrost meat in the microwave, other people will do it this way, where you put a piece of frozen meat in a warm bowl of water, and eventually it'll defrost because they'll become the same temperature. The water, the actual coldness of the meat, will melt because the water is warmer than the meat. So the heat will transfer from the water to the meat, okay? You need to know which direction it goes. All right. Now, it's important to know that there are substances that transfer heat better than others. So we mentioned this with the metal and the wood earlier, okay? There's such a thing as a thermal conductor, okay? Thermal conductors just mean that it's the substance that transfers heat very well. So metals are an example. Silver, copper. They're really good transfer of heat, okay? So here's some others. Silver, gold, copper, steel, and seawater actually. Heat transfers very well in salty water, okay? And the opposite of that is a thermal insulator, okay? Thermal insulators just mean that it does not conduct heat well, which means the heat doesn't travel through that substance as well as it would with a conductor, okay? And some examples of these are glass, wood, like we talked about earlier, rubber, plastic, okay? And then we have here diamonds and oil, okay? Also, air is an important insulator, okay? So let's kind of break this down a little bit. We know that both of these things are important, okay? And you could think about this in terms of electricity, because we actually use copper wires very often to conduct electricity because they conduct heat very well. They can transfer the heat very well. Okay, that's really important to know that we have conductors, but also we don't want to be electrocuted. So a lot of times they'll put copper wires and they'll insulate them with rubber or plastic. Okay, and the reason why they do that is because now the heat cannot escape from the wire. Does that make sense? I feel like I'm waiting for a response back, but you guys are going to listen to this later. But another example is air, okay? A lot of times, okay, so think of your hydro flask, okay? The hydro flask is a really good insulator because there's probably air in between the two layers of the water bottle, so it insulates either the cold or the hot. That's what a vacuum insulator is, okay? So both of those things, very important, right? All right. Oh, one more example that I was going to mention is in your house. Maybe you have double pane windows, which means that there's two panes of glass and then there's air in the middle. That makes a very good insulator, both for warm and for cold. For example, if you live in a cold place and you put the heater on and you have double pane windows, the heat is it's not going to escape outside the house very well, which is good. But then if you live in a really hot place like we do, double pane windows are also very good because we want to keep the cold air in. We don't want the heat to come inside. So the double pane windows will help us with that. Okay? All right. We'll take a pause here and take a look at a verse. This verse says, I praise you because I am fearfully and wonderfully made. Your works are wonderful, and I know that full well. This is David writing this verse. Psalm 139 is a really awesome chapter in the Bible. So I want to take a minute and just kind of look at God because it's amazing. Our creation is amazing. And the more we study it, the more we can learn and worship God for what he's doing and what he did. I love life science. Many of you know that, and studying life and the human body and things like that. So I want to explain something that relates directly to conduction. And because we were talking about insulators, the human body tissue actually is a really, really good insulator. We talked about in our last PowerPoint that we are able to maintain body temperature. Remember when we were talking about shivering? So your body tissue actually is a great insulator. It helps to keep the inner core of your body warm in a cold environment. Okay, and I want you guys to think about this question. What do you think would happen if God had not designed the human body this way? So if our body was not a good insulator and we couldn't keep heat in, if God did not design our body this way, but he did because he's perfect and he made us perfect, what would happen? What do you think would happen? Okay, think about that. All right, let's move on. All right, then we have convection. So we talked about conduction, now convection. Okay, convection is, this is why it happens. Okay, so the fluids and gases flow in a circulation of currents. We talked about that already. They go from one region to another. If there's heat on top, then it's going to move to the bottom where there's cooler air. If there's heat on bottom, it's going to go up to the top, and it continues to circle and circle and circle. There's some really cool things that happen when this takes place. Okay, here's an example. If you've ever watched a hawk or an eagle that are like looking for prey, they kind of go in circles. The reason why they actually go in circles when they're looking for their prey is they're not spending as much energy doing that because they're riding the air currents. There's natural air currents that go on in our atmosphere, and the birds just jump right into those air currents and then they just glide. And so they're not actually using their wings, flapping their wings all that much. They're just gliding on the air currents, which is really cool. Another example, and here's this picture. This is a picture of the International Balloon Fiesta. This is actually not far from us. It's in Albuquerque, New Mexico. So here's an interesting thing. In Albuquerque, it is the only place in the world where the air currents are suitable for this festival. And what the festival is they send thousands of balloons up in the air all together at one time. And it's really, really cool. I know it sounds lame, but if you ever get a chance to go, you'll be amazed. And so the reason why it takes place in Albuquerque, though, is because of the air currents. The air currents basically go in a circular motion, kind of like they go right on the bottom, up, and then left. Okay, so if you're looking at my mouse, that's kind of how they go. And why that's important is so the balloons don't run into each other. And so they're all going to take this circulation of current, and they're all going to follow that, and they're not going to run into each other, which is really, really cool. All right. Okay, so how then does convection work? What's the science behind it? All right, let's take a look. It's the cycle of rising and sinking of air or liquid. The warmer part of the fluid or liquid, or fluid or air, becomes less dense and rises. It carries the heat with it. So it has to do with density, okay? The warmer part is more dense, actually. Or sorry, less dense. And because it's less dense, it rises, okay? And so the cold air sinks, and then it rises, and then the cold air sinks. And it goes on and on and on, and it creates a current. All right? And here's some examples. We have, actually, this is Earth's weather patterns, okay? This is the worldwide weather patterns. There's also weather patterns just in North America, but this is in the whole world, which is kind of cool. So this is how we have weather. So we have rain and sun and wind and sleet and hail and snow. Those things are caused by the currents that take place in our world and in our little bubble here in North America. All right, which is pretty cool. There's wind patterns. There's also ocean patterns in the water because remember it's air and liquid. There's ocean patterns that take place. And so there's ocean currents that create a transfer of water from different places to another. And this is important because it transports nutrients. And I'm sure most of you have probably seen Finding Nemo when they take the current, I forget what it's called, the Australian current, that's caused by these circulation of water, which is pretty cool. And then I wanted to mention this, if any of you have a convection oven in your house, it's a convection oven because it circulates the air, which it turns out to be a really nice oven because it cooks the food very evenly. Okay? All right, we're almost done. Lastly, we have radiation. Okay? Radiation is unique because it doesn't need a medium. What do I mean by medium? Well, when we talked about conduction, it needs to be touching direct contact. And then when we talked about convection, it needs to have a circulation of either air or liquid, but there's something that's going on there. Well, radiation travels, the energy travels through space by waves or rays, okay? So for example, the sun's heat reaches the earth and the rest of the solar system through radiation. Also, if you're roasting a marshmallow, if some of you like it burnt, so you probably get it in the water, but if you wanted to just radiate the marshmallow, then you would just hold it over the flame. You wouldn't touch it to the flame, but the marshmallow would still cook. And in my opinion, that's the best way to cook them. Cook them, don't touch the flame, and that's called radiation. If you touch the flame, that turns into direct contact, which is conduction. Okay? All right, one more, just fun fact. Let's talk about fossil fuels. This is really interesting. You all probably know what fossil fuels are. We have oil, coal, and natural gas. Okay, and fossil fuels are basically fossils that have turned into these things over time. Now, they have energy, and if we burn them, then we have energy for our houses, cars, and such and such. Well, where did that energy even come from? Right? That's a good question, isn't it? Well, the sun actually provides radiation. Remember, the radiation goes into the earth, and we know that we can do solar panels for energy, but also these fossil fuels, that once were living creatures and then turned into fuels, they have energy because they have soaked up the sun's rays. So that radiation is soaked up in them, and so we have energy that is stored, ready to be used, that was originally from the sun. So then when we burn these things, the energy gets released. Okay, this is the same thing if you burn wood. Now, wood is not a fossil fuel, but if you burn wood, it's the same thing because it has soaked up some rays of energy, and because of that, we're able to get energy, and the energy is released, and we can use that energy from it. Okay? All right, that's it for this PowerPoint, you guys. Have a good day.